Look around you. What do you see? Maybe a phone in your hand, a refrigerator humming in the background, or a car speeding down the street. What you might not see is the unseen force that connects them all. Magnetism. It's a fundamental force of nature as powerful as it is mysterious. Though we can't see it, we experience its effects every single day. Magnetism is the silent partner in our technological world, working behind the scenes to power our devices and connect us across vast distances. But its story isn't confined to the modern age. For centuries, humans have been both fascinated and perplexed by this invisible force, striving to understand its origins and harness its potential. This is the story of that journey, the magnetic journey. Welcome to this episode of Timeline of Innovations, where we explore the magnetic journey, from ancient lodestones to modern marvels. Don't forget to like and subscribe so we can bring you more videos. Think about the last time you used a credit card, or the last time you listened to music on your headphones, or even just opened a door with an electronic lock. Each of these actions, though seemingly ordinary, relies on the power of magnetism. Our world is built on a foundation of magnetic principles, even if we rarely stop to consider them. Without magnets, our lives would be drastically different. Communication as we know it would cease to exist. Transportation would be limited to pre-industrial methods. And many of the medical advancements we take for granted, like MRI scans, would be unimaginable. The sheer ubiquity of magnets in our lives speaks volumes about their importance. They're the unsung heroes of the modern age, silently enabling countless technologies that we now consider indispensable. But how did we get here? How did we go from simple lodestones, naturally occurring magnetic rocks, to the sophisticated magnetic applications we see today? Our exploration of magnetism begins not in a state-of-the-art laboratory, but in the natural world. Thousands of years ago, long before the scientific method or the invention of electricity, humans encountered magnetism in its rawest form, the lodestone. These naturally magnetized pieces of iron ore, also known as magnetite, held the first clues to this unseen force. Ancient civilizations in China and Greece were among the first to recognize the peculiar properties of lodestones. They observed that these stones had an uncanny ability to attract iron and, even more intriguingly, to align themselves in a north-south direction. These early observations, though simple, marked the beginning of a long and fascinating journey. A journey that would ultimately lead us to unravel the mysteries of magnetism and unlock its extraordinary potential. Imagine yourself in a time before electricity, before engines, before the hum of modern technology. The world was a quieter place, governed by the rhythms of nature, and the forces that shaped it were often shrouded in mystery. It was in this world, amidst the rustling leaves and the whispering winds, that ancient civilizations first encountered the enigmatic power of magnetism. Their introduction to this invisible force came in the form of the lodestone, a naturally occurring magnetic rock. These unassuming stones, often found near the Earth's surface, possessed a curious property. They attracted iron. This seemingly magical ability set lodestones apart from ordinary rocks, sparking curiosity and wonder in those who encountered them. The attraction between lodestone and iron wasn't the only thing that captivated early observers. They soon discovered that when suspended freely, a lodestone would consistently align itself in a particular direction, pointing towards the north and south poles of the Earth. This directional property, so different from anything else in their experience, hinted at a hidden order within the natural world, a force that transcended their understanding. The earliest written records of magnetism come from China, dating back to the 4th century BCE. The Chinese referred to the lodestone as Ci Shi, meaning loving stone, a testament to its ability to attract iron. They were fascinated by its properties and sought to understand its nature, incorporating it into their philosophies and practices. Ancient Chinese philosophers believed that the lodestone's ability to attract iron was a manifestation of qi, the vital energy or life force that flowed through all things. They saw the lodestone's directional property as evidence of a harmonious balance between heaven and earth, a cosmic connection that influenced the flow of qi and, by extension, the events of the world. Beyond its philosophical significance, the lodestone also found practical applications in ancient China. It was used in geomancy, a practice that sought to harmonize human dwellings with the Earth's energy, and in divination, where its movements were interpreted to predict the future or guide decision-making. These early uses demonstrate the profound impact that magnetism had on Chinese culture, shaping their understanding of the world and their place within it. Across the world, in ancient Greece, the lodestone was a source of fascination. The Greeks called it magnetis lithos, meaning stone from magnesia. Legend has it that a shepherd named Magnus discovered the lodestone on Mount Ida. The story of Magnus highlights the wonder surrounding the lodestone. It was a force both familiar and mysterious, capable of exerting an invisible pull on iron objects. Despite their differing cultural interpretations, both the ancient Chinese and Greeks recognized the lodestone as something extraordinary, a testament to the hidden forces at play in the world around them. They observed its effects, experimented with its properties, and incorporated it into their beliefs and practices. Their encounters with the lodestone marked the beginning of a long and winding road of discovery, a journey that would span millennia and lead to a profound transformation in our understanding of the universe. From these early observations, the seeds of scientific inquiry were sown, eventually blossoming into the field of magnetism as we know it today. The lodestone, in its unassuming way, served as a bridge between the ancient and modern worlds, connecting us to the curiosity and ingenuity of our ancestors who, armed with nothing more than observation and imagination, dared to explore the mysteries of the unseen world. Their legacy lives on in every compass that guides our way, every motor that powers our machines, and every scientific breakthrough that pushes the boundaries of human knowledge. For centuries, the lodestone's ability to align itself north-south remained a source of wonder and speculation. Some saw it as a mere curiosity, a strange quirk of nature with no practical application. Others, however, recognized its potential to revolutionize a fundamental human endeavor: navigation. Imagine the challenges faced by ancient mariners navigating vast oceans. Without landmarks or a clear view of the stars, they relied on the sun and the winds to guide their way, often at the mercy of unpredictable weather and treacherous currents. The lodestone, with its unwavering north-south orientation, offered a tantalizing solution, a way to maintain course even when the heavens offered no guidance. The earliest attempts to harness the lodestone's directional properties were rudimentary yet ingenious. One method involved suspending a lodestone from a string, allowing it to rotate freely until it settled into its north-south alignment. By marking the direction indicated by the lodestone, navigators could maintain a consistent course, even in the absence of familiar landmarks or celestial cues. This simple yet profound innovation marked a turning point in human history. It paved the way for the development of the compass and the age of exploration that followed. The transition from a simple suspended lodestone to a more sophisticated compass is shrouded in some mystery. The first true compasses emerged in China between the 11th and 12th centuries. These early compasses, often referred to as south-pointing needles, differed significantly from their modern counterparts. Instead of a magnetized needle, they used a lodestone spoon on a bronze plate. The invention of the compass had a profound impact on navigation, particularly maritime navigation. This newfound navigational freedom opened up new trade routes and facilitated cultural exchange. The compass, once a closely guarded secret of Chinese navigators, spread westward, reaching the Arab world by the 13th century. Arab scholars quickly recognized its value, incorporating it into their practices and refining its design. They developed a dry compass, using a magnetized needle balanced on a pivot. This made it more compact and easier to use on ships. Arab navigators disseminated the compass throughout the Mediterranean, introducing it to initially skeptical European sailors. By the 14th century, it became indispensable for European exploration. The compass, born from the ancient discovery of the lodestone, stands as a testament to human ingenuity and our relentless pursuit of knowledge. It transformed navigation, connecting distant cultures and expanding our understanding of the planet we call home. From ancient Chinese sailors navigating by the stars to European explorers charting new worlds, the compass has played a pivotal role in shaping the course of human history. And while today's sophisticated GPS systems have largely replaced the compass for most navigational purposes, its legacy endures. The compass remains an important tool for backup navigation, wilderness exploration, and even simple orientation. More importantly, it serves as a powerful symbol of exploration, discovery, and the enduring human spirit that continues to seek out new horizons, guided by the unseen forces that shape our world. For centuries, magnetism remained shrouded in mystery and superstition. The lodestone, with its invisible powers, was often seen as magical. Ancient civilizations used magnetism for navigation, but its true nature was elusive. The Renaissance brought a new era of scientific inquiry. William Gilbert, a pioneering English scientist, sought to unravel magnetism's secrets. Gilbert's rigorous experiments transformed magnetism into a legitimate field of study. Gilbert's fascination with magnetism stemmed from a deep desire to understand the Earth. He recognized the lodestone's north-south alignment hinted at a global force. Could the Earth possess a magnetic soul influencing the compass? Gilbert embarked on groundbreaking experiments. He crafted a spherical lodestone, the Torella. The compass needle's behavior on the Torella mirrored Earth's. This experiment showed Earth as a giant magnet. Gilbert's work was a watershed moment in magnetism. It laid the foundation for our understanding of Earth's magnetic field. In 1600, William Gilbert published a comprehensive treatise on magnetism. This groundbreaking work presented Gilbert's findings systematically, with detailed illustrations. Gilbert debunked myths about magnetism and coined the term electricity from the Greek word electron. His work inspired scientists like Kepler and Galileo, contributing to the broader scientific revolution. Gilbert's legacy laid the groundwork for modern science. William Gilbert transformed magnetism into a legitimate field of scientific inquiry. His meticulous experiments and laid the foundation for understanding Earth's magnetic field. Gilbert's approach to scientific inquiry emphasized observation, experimentation, and challenging established dogma. His spirit of inquiry lives on in scientists like Faraday and Maxwell. Gilbert's legacy reminds us that the pursuit of knowledge requires curiosity and skepticism. As the Industrial Revolution dawned, magnetism remained largely confined to the compass. The scientific community, inspired by Newton and the Enlightenment, sought to explore deeper mysteries. Brilliant minds suspected a hidden connection between electricity and magnetism. Electricity was seen as a static force, while magnetism was associated with lodestones and compasses. Few suspected these forces were connected, but early 19th century experiments would reveal their relationship. This discovery would forever change science and technology. Ørsted's accidental discovery, bridging the gap. In 1820, Hans Christian Ørsted discovered that electricity could produce a magnetic effect. While he experimenting with a voltaic pile, he noticed a compass needle deflecting due to electric current. Ørsted's discovery challenged the prevailing understanding of physics. Scientists across Europe replicated his experiment, eager to explore electromagnetism. This discovery opened new avenues for research. The race to unravel electromagnetism had begun. Faraday's breakthrough unveiling the electromagnetic dance. Michael Faraday, intrigued by Ørsted's discovery, explored the relationship between electricity and magnetism. Faraday hypothesized that magnetism could induce an electric current. His experiments led to the discovery of electromagnetic induction. This discovery formed the foundation for electric generators and transformers. Faraday's work powered the modern world. The combined discoveries of Ørsted and Faraday ushered in the electric age. Engineers harnessed electromagnetism, transforming technology. The telegraph, an early application, revolutionized communication. Faraday's principle of electromagnetic induction led to the electric generator. This invention transformed how we light our homes and power industries. The discovery of electromagnetism marked a pivotal moment in history. The legacy of Ørsted and Faraday continues to shape our world. The late 19th century saw an explosion of technological innovation. Electromagnets generated strong magnetic fields through electric current. Unlike permanent magnets, electromagnets offered control and versatility. Electromagnetic induction formed the basis for electric motors. Early electric motors powered various industries. Electromagnetism transformed the society. Electromagnetism revolutionized communication. The telegraph allowed messages to travel at the speed of light. Alexander Graham Bell's telephone transmitted the human voice over long distances. The telephone connected people in unprecedented ways. Electromagnetism transformed commerce, diplomacy, and personal communication. The impact on society was revolutionary. The electric generator transformed how we lived and worked. By rotating a coil within a magnetic field, engineers generated electricity. Early generators were driven by steam engines or water wheels. The electric generator powered factories, homes, and transportation. It marked the beginning of the electric age. Electromagnetism changed human civilization. Magnets became integral to modern life. Electric motors found in everyday devices convert electrical energy into mechanical motion. Magnets are essential in speakers, hard drives, and medical imaging devices. They play a crucial role in renewable energy technologies. Magnets power communication, transportation, and healthcare. The journey of magnets is one of relentless innovation. Probing the invisible magnetic resonance imaging. As the 20th century unfolded, magnetism's power extended into modern medicine. MRI harnessed magnetic properties of atoms to visualize the human body, revolutionizing medical diagnostics. The story of MRI begins with the discovery of nuclear magnetic resonance, NMR, in the 1930s and 1940s. NMR revealed information about atoms' chemical environments, laying the foundation for MRI. In the 1970s, researchers used NMR to create detailed images of the human body. MRI uses magnetic fields and radio waves to generate cross-sectional images of organs and tissues. Unlike X-rays, MRI is non-invasive and poses no known health risks. Today, MRI is essential in diagnosing conditions like tumors, strokes, and neurological disorders. Its detailed images of soft tissues have revolutionized medical diagnostics, improving the patient outcomes. The digital revolution on magnetic tapes. While MRI revolutionized medicine, another magnetic innovation reshaped data storage. Magnetic tape recording emerged in the early 20th century, evolving to become the backbone of data storage. It began with the wire recorder in the late 19th century. This device used a magnetized wire to record sound but had limited storage. The 1930s invention of magnetic tape revolutionized audio recording. Magnetic tape offered higher fidelity, durability, and easy editing. During World War II, magnetic tape technology advanced rapidly. Post-war, it transformed the music industry with reel-to-reel and cassette tapes. Its impact extended to data storage, recognized by computer scientists. In the 1950s, magnetic tape data storage systems were developed, offering greater capacity. Section 3. Levitation and Propulsion Maglev Trains. The idea of a train floating above the tracks, propelled by an invisible force, might seem like science fiction, but thanks to magnetism, this vision is now a reality with maglev trains. Utilizing magnetic levitation and propulsion, these trains promise faster travel times and smoother rides. Magnetic levitation is simple, like poles of magnets repel each other. Powerful electromagnets lift the train above the guideway, eliminating friction. This allows maglev trains to achieve higher speeds and smoother rides. Maglev trains are also propelled by magnetic forces. Controlling electromagnet polarity creates a traveling magnetic field that pulls the train forward. This method allows maglev trains to reach astonishing speeds. Despite challenges, maglev trains are operational in Japan and China, demonstrating the viability of this futuristic transportation technology. Magnetism at the frontiers of technology. As we stand on the cusp of a new technological era, magnetism will continue to play a pivotal role. From the smallest scales of matter to energy production, magnetism's invisible hand guides us towards a future filled with promise. One exciting frontier is quantum computing. Unlike classical computers, quantum computers use qubits, which can exist in a superposition of states. This allows quantum computers to perform calculations impossible for classical computers, revolutionizing fields like drug discovery and AI. Magnetism is crucial in quantum computing, especially in creating and manipulating qubits. Many qubits rely on magnetic fields to maintain their states. As researchers build larger quantum computers, new magnetic materials and nanoscale control techniques will be essential. While magnetism's future is filled with exciting possibilities, it also faces significant challenges, particularly concerning the sustainability of the materials used to create magnets. Many high-performance magnets rely on rare earth elements which are difficult and environmentally damaging to extract. This has spurred a global search for alternative materials that can match the performance of rare earth magnets. Researchers are developing new types of magnets, such as iron nitride or manganese-based magnets. Another approach is to improve recycling and reuse of rare earth magnets. The quest for sustainable magnetism is an opportunity to rethink our relationship with these materials. Our journey began with a simple rock, a naturally magnetized stone that captivated ancient civilizations with its ability to attract iron and align itself with the Earth's invisible magnetic field, leading us from ancient compasses to MRI machines and quantum computers. William Gilbert's experiments revealed Earth as a giant magnet. Ørsted discovered electromagnetism, and Faraday's work laid the foundation for the electric age. From mysterious rock to quantum labs, the story of magnetism is a testament to human curiosity and ingenuity. Today, magnetism's influence is all around us, woven into the very fabric of modern life. It's in the motors that power our appliances, the generators that electrify our homes, the speakers that fill our lives with music, and the hard drives that store our digital memories. It's in the MRI machines that allow doctors to diagnose and treat diseases, the Maglev Trains that whisk passengers at astonishing speeds, and the wind turbines that harness the wind's energy to power a cleaner future. We often take these technological marvels for granted, rarely pausing to consider the invisible force that makes them possible. Yet, without magnetism, our world would be a vastly different place. Communication would be limited to the speed of transportation. Our understanding of the human body and the universe around us would be far less sophisticated, and many of the technologies we rely on for energy, transportation, and healthcare would simply not exist. Magnetism's influence extends far beyond the realm of technology. Earth's magnetic field, generated deep within our planet's core, acts as a protective shield, deflecting harmful radiation from the sun and enabling life to flourish. Migratory animals, from birds to sea turtles, navigate vast distances using Earth's magnetic field as a guide, demonstrating the profound influence of this unseen force on the natural world. As we look to the future, magnetism's role in shaping our world will continue to grow. Researchers are exploring new ways to harness this force, promising breakthroughs in medicine, energy, and computing. Quantum computing relies on magnetism for creating and manipulating qubits. New magnetic materials and designs are paving the way for cleaner energy sources. Magnetic levitation technology promises faster, smoother, and more energy-efficient travel. The demand for high-performance magnets raises concerns about resource scarcity and environmental impact. This challenge encourages innovation in alternative materials and sustainable practices. By fostering innovation and prioritizing sustainability, we can create a brighter future. This concludes our episode on magnetism. Join us for our next video in Timeline of Innovations. Please like and subscribe. Until next